Broadcasting live from our studio in Boston, Solutions Review is proud to showcase Broadcom in the Solutions Spotlight, a unique online event for industry professionals.
I'm Doug Atkinson here at Solutions Review, and welcome to the Solutions Spotlight featuring AppNeta by Broadcom, and focused on how to gain comprehensive visibility of your business-critical apps and networks. While network and application performance grow increasingly business-critical, IT's ability to track and control service levels continues to be diminished. The shift to hybrid and remote work means users are now highly reliant upon public internet connections, which require additional security at the network edge. Plus, the majority of apps, internal or external, are now cloud hosted. So today, we will focus this solution spotlight on AppNeta by Broadcom, which offers SaaS-based application and network performance monitoring for any cloud, every user, and all locations. And to walk you through this presentation is Alec Pinkham, Product Marketing at AppNeta. Alec, thanks for being with us.
Yeah, thanks for having me.
Well, I'm glad you're here because I think this is an interesting topic. It's one of those ones that we get at Solutions Review that get more and more important as the world gets more and more complex, if you will. And I know you've been with AppNeta for quite a while, and I'm curious, before we get going, if you could just share a little bit more about your background and your role there at AppNeta.
Yeah, of course. So I've been with the AppNeta product line for about 8 years now. So we've been 2 years at Broadcom almost. Before that, I spent some time in the engineering world, quality assurance, software engineering, and then moved to product management, but realized that the best way to talk to customers and kind of tell the story, marketing tended to be the way to do that. And so I found the weird niche of product marketing where I get to be technical, but I still get to be the storyteller and talk about the products that I'm passionate about. So.
Yeah, well, this is like I said, this is an interesting one. Actually, there's a turn of a phrase on the Broadcom website that says "ensure remote work works," which I think is a really interesting way to say it, and I think that's something that everybody is going to be interested in hearing more about. So before we get going, let me set expectations for everybody. If you have any questions, by all means, submit them. I'm going to hold them here until Alec is done with his presentation, then I'll spin back in and we'll go through some questions at the end. We'd love to make it interactive, so again, if you have anything that you'd like to know more about as the presentation goes along, just shoot them on in and we'll take them as they come. Otherwise, Alec, I'm going to turn it over to you now. I know you've got some presentation and demo, so I'm going to give you all the room you need, and when you're wrapping up, let me know and I'll jump back in.
All right, sounds good. Yeah, I think the goal today is to kind of go back and forth between the story and how we actually do it in product. I think there's a little bit to be said to set the stage and kind of level set on what we're going to be talking about, as well as what the product can do. So, first I want to discuss kind of what's different for network operations teams and IT teams with modern networks, right? We've mentioned that they're complex, right? What actually is different about them that we need to worry about when we come to the monitoring and the end user experience part of it? So we'll be looking at the monitoring concept called error domains, and then go into kind of 3 best practices that we've gotten from customers around getting visibility into those dynamic networks, what actionable data you actually need, and then how we actually validate performance and quality. So if I can start with essentially the current state of networking, right? The title is end user experience here, but this is nominally about users and applications. In a sense, it's actually really about the network, though. The network is the connective tissue between your users and your applications. And as we've adopted cloud, as we've migrated workflows to the cloud, we've now put this physical and logical distance between our users and our applications. You put on top of that the pandemic, as well as the move towards remote work. You now have people like myself calling in from various locations. We're going over VPN into our corporate locations, or we're going, split tunnel out to a direct to cloud for things like StreamYard here today. We also have this kind of dependency on these ISP networks that IT doesn't own anymore, right? The transit networks, the residential ISPs for remote work, as well as a lot of offices that have moved towards a SD-WAN setup with multiple different ISPs, maybe a primary and a backup, or maybe routing traffic specifically over each one of them. We have a lot of these dependencies on networks we don't own, and they're outside of the four walls of the office, the headquarters, the data center, but they're also outside of our control. And so we'll get into that a little bit, right? So I want to make sure that we're talking about networking here, right? End user experience, performance, quality of experience, all of these things rely on a good network. And what is a good network? How do we measure that? How do we monitor it when it's outside of our control? That's really the crux of the issue that we want to get to. And so if we first think about where we are, right, we're likely in a cloud first world, right? I always love these analyst quotes, and this one's, just a year or so old here, right? Next year is the year of the cloud. The next year is going to be the big one for cloud, right? It shows that not only we're already here in the cloud, but also there's just so much more to come. There's so many more cloud related technologies that you get every year that we rely on that we didn't rely on 5, 10, or even a couple of years ago. So if we were in person and we did show of hands, it's like, who's moving something to the cloud? Everyone, right? Everyone's moving something to the cloud. Now, some things are getting clawed back to the data center because cloud isn't the perfect spot for them. That's fine, but cloud is pervasive. Right. So with this cloud growth, it leads to these new and kind of interesting challenges with networks that we don't own, with applications that are now outside of our control, and the user experiences are getting harder and harder to measure, to quantify, and also to really understand where traffic is going today. And so we have a user experience problem, right? If cloud is pervasive, then networks are critical, right? The approach we have to take is going to take into account the whole problem. And that's why I really harp on this idea of end-to-end visibility. And we're going to come back to that a couple times today, right? Where are the apps today? If they're in the cloud, right, where's the user? Is the user at home? Is the user traveling? Is the user in the office, right? We've introduced that physical logical distance that I mentioned. But when we think about that distance for network operations, the visibility part becomes critical because they don't have the same traditional approaches. You can't pull SNMP data from an ISP device. You can't pull it from a cloud device that you don't own, right? You can't pull network statistics and understand if there's an outage somewhere along the link between users and applications. We have a number of customers that have smaller centralized IT teams now because you can do things like remote packet capture, remote triage. But if they're centralized, then you may not only know, like, you might not know where that user is. You might not know what their ISP is. You're not going to know what their home setup is. It's not like you rolled out those access points anymore. And so we have these problems of visibility. And so when we're talking about managed networks that we own, we have the full control of those. Those are still critically important to business traffic, especially in the office, and especially if you have your own internal applications. But it's not enough when we talk about the way we're adopting cloud, the speed at which we're adopting cloud, and the speed at which technology is kind of changing there. So I think we need to supplement the managed network visibility with that external network visibility. So, at the end of the day, in order to understand the end user experience piece, you need instrumentation from the user to the application. And that's going to come in different types, right? But why do we really need those, right? The modern networks that we work on are dynamic, right? Cloud ISPs especially design their systems so that if there's a failure in one location, it will be traffic will be routed to a different location or through a different transit network, right? Load balancing, hot to hot, standby, just really the software defined networking in general that we see, right? It's very dynamic, which means that your path that you take to Gmail or Microsoft Teams or something like that this minute is not going to be the same in 5 minutes if you refresh, right? Or it's not going to be to the same endpoint, right? It could be a totally different server. It could be in a totally different region if the problem in the ISP is big enough where it has to route you farther away, right? So we get all of this, dynamism in the network, which means it's incredibly difficult to get visibility into those, especially when network teams and IT teams, level 1, level 2 triage, that's going to be after the fact, right? That's going to be having to look back in time and see where that route and where that traffic was going at that time. Rewinding the clock is very difficult when you have these kind of changes, because you have to be constantly looking. You have to be continuously monitoring in order to understand what happened an hour, 2 hours ago when that ticket came in, right? These networks are complex, right? We balance, in the ISP terms, we balance the reachability, the reliability, and the performance, right? But the idea is that it's always up, right? When we talk about internet, when we talk about these larger networks, the idea is to have a big enough mesh and a good enough reliability that the network is always up. It may get slow at times, but it's not down, right? Outages make news. When it's just slow, you typically, the first thing you're going to do is say, oh, network's a little wrong. I'm going to go grab a coffee. I'm going to go, take a quick break, and then I'll come back. And then maybe if something's going wrong with a specific applications, maybe you can pinpoint it if you're a smart enough user or know enough about networking. Pinpoint it to a specific app. Maybe you check a status page. Maybe you ask a colleague what's going on with that network. But at the same time, we're kind of pushing out the timeline of when I actually contact IT. And so if it's dynamic, if it's complex, then I'm not giving IT all they need, because I'm not telling them until much later, right? Lastly, as I mentioned, it's out of control. It's out of IT's control. It's out of network operations control. It's out of the enterprise control. Whether or not you're a large communication provider yourself, right? There's going to be peering in some places where you probably don't have visibility into those. And the modern issue that we also need to talk about is the fact that we don't really have SLAs, right? You're guaranteed bandwidth, not the end-to-end capacity, right? Capacity is really talking about the achievable bandwidth from end to end. So what can you actually get through the pipe? What's the bottleneck? What's the smallest part of the pipe between two locations? Bandwidth is at your door, right? And then you hop on the link with everyone else that's in your metropolitan area, your city, or if it's your residence, then it could be, your street, right? And so there are a lot of different bottlenecks in places where you can run into problems. But if you're not looking at those, if you're not getting the visibility that we're talking about, then you're blind to those. All right. So let me give you an example, right? With all that in mind, we do need a new approach. We need an active approach, right? And this is not unproven ground, right? One of the example I have here is pharmaceutical manufacturing, right? The problem that we've talked about is kind of abstract, but let's discuss kind of a real world example, right? This is a pharmaceutical company with global footprint. They have basically research arms and development arms for medicines for serious diseases, right? The key to that work is the performance of a large network, right? It's data being transferred across these locations for employees on the R&D side. It's internal and external applications, right? The end user experience is based on these two different parts of the silo, right? So how do you guarantee the performance and availability for an application across these third-party network providers, right? The customer, in this case, called out this issue to us, right? So they're working across 4 different clouds. So they have a hybrid multi-cloud setup. They're routing and backhauling traffic through Equinix, right? For security control, for all the reasons you do that, right? They didn't understand the routes between offices, their data centers, and the cloud, right? And so understanding, as I mentioned, those bottlenecks was the problem for them, right? They have the internal apps, right? They've migrated those to the cloud. And so they've put that physical logical distance between user and application, right? They're monitoring all types of connections. So the office to data center, site to cloud to cloud, right? North, south, east, west, all the ways you can think about it. But because they're using that external network management through Equinix, they're also backhauling. They're introducing a lot of latency as well as an inability to actually see it for themselves, right? Equinix is monitoring it, but what are they actually seeing, right? The reporting wasn't right for them. So it boiled down to visibility for them in this case. And you can see on the bottom right there, the result is that they had to look through these SASE services, right? These edge services to understand what the performance hit of security was. There's always going to be a trade-off between security and performance. And we know that over the past couple of years, security has been in the spotlight. Totally makes sense. We understand that. But there needs to be visibility on the performance side so we can understand what the impact of that security is. Because it might lead to a change. It might lead to a really kind of jiggering or re-understanding of what apps do we trust, right? Which ones can we go directly to? Which ones do we need to backhaul? Right? Do we need to do it all? Right? There are some verticals as well as some industries where that is totally necessary, and we get that. But we need to use the kind of the visibility angle to understand what the impact is on the end user and on performance. Because if it starts impacting user performance, productivity, there's a pretty quick tie to revenue in a lot of cases, especially when you're in specific industries. If you think about, retail or, business process outsourcers that are doing call centers, right? If you take people off the phones, that makes wait times longer, which could immediately impact customer satisfaction. So there's a lot of different issues that we can see there. Right. So in this case, and in many, we're working with the network operations team. But the question for when things go wrong is who's accountable for the ownership here. Right. So if you're in the development side, right, and you can make the fastest app on the planet, but the network still has to deliver it and the network goes down, right, you get pulled into a war room, and development needs to show that, oh, the app is up. If it's a DevOps scenario, right, they have to show that the app is up, it's running, we can connect to it. But if you're in the cloud ops side, maybe you've got great east to west views, but you don't have the north south or vice versa, right? If you're in IT, you may know what's going on in between the four walls of the office, the data center. But what about those cloud apps? What about the delivery path, the network delivery path out to those applications from your locations? So in reality, it's going to take all of these different opinions, but the most successful companies that we work for, right, bring these teams together and bring this visibility together before the war room, right? Give all the teams the insight, right? It doesn't have to be the same tooling. We know teams fight over tooling, right? Use your tool, but then export it to a centralized NOC view or a centralized thing. So that's one thing that we always talk about, is making sure that the systems are open, right? So we know that these organizations work well. And so what we've done is we've taken kind of 3 of the best practices from them and we've put it into this presentation. And so that's what I'm here to talk about today, right? So it's embracing the reality of dynamic networks, plan around them, right? It's assuming the dynamic network, and then when you use the testing methods that we're going to take into account, and what we're going to talk about, right, that's where you get into the visibility. So second, actionable data set, right? We know there's a ton of data out there right now, right? But what makes data actionable? What can we do with that data? And what specific data are we looking for when we talk about network performance or network experience, or in this case, end user experience? And then third is really about monitoring from multiple perspectives, right? Don't just monitor in the traditional ways, SNMP, passive polling. We need to do an active approach, and we need to take into account where the users and the applications are. So we're taking that perspective into account. So to introduce these 3 ways, I want to bring it back to one of the things I teased earlier, was really to talk about the error domains. And so this really is about app and end user experience, but there's a lot in the middle of these 2 extremes, right? There's a lot of network tissue. There's a lot of devices between those. So if we're going from left to right, we're just segmenting that delivery path. We're segmenting it into the end user domain, the last mile ISP. What's the, the actual provider? It might not always be an ISP, but what's the service provider outside the door? Where's the transit backbone, the peering relationships, and then where's the application service provider infrastructure? And so when we're looking left to right, the office, the Wi-Fi, the home, right, could be an airport, right? In these cases, the office, IT and network operations teams, you have ownership of the devices, right? The access points for wireless, the firewalls, all of that, right? In others, you're not going to. So remote offices, remote users, it could be, an asymmetric residential link from, a Wi-Fi router from 5-10 years ago on, 2 standards back, right? Being able to isolate the scope and understanding those from a user perspective is really, really helpful for network operations teams when it comes to triaging and understanding the problem. Right. So the last mile ISP, that's the next one. It's a black box, right? Understanding what's going on there takes an active approach. You can't passively gather data from them, right? It's more than traceroute. We're not just using that to find the devices. We're actually testing through that and testing to each of those devices to fully map that network, right? Because that's the dynamic one, or one of the most dynamic ones that we talked about, right? Transit backbone networks, typically we don't have to worry about speed here, but the dynamic nature, load balancing, the switching and peering, right? You may have downstream switches that are, not your last mile ISP's fault, but is something that's part of the service from you to the application. So understanding when those are a problem or when those are in the kind of in the spotlight, we need to know. And then the app service provider environment, that's going to be one of the most dynamic natures everywhere. If you look at Google, Microsoft, all the big cloud providers, AWS, right? Those are load balanced all over the place. They have, backbones between them, depending on how you do it. If you think about something like Microsoft Teams, right? There are a ton of specific regions in Microsoft's cloud that are just Teams regions, right? Not all of them are, but most of them are. I think there's 38 Teams region or something like that. The difference is that when you host a call, right, the way that they set it up is that you actually you transit to the host's region, right? And there are a couple different ways that they've changed it over the years, but understanding, the relationship between where your traffic is going versus where a colleague's traffic is going is really, really helpful when IT has a discussion, says, hey, Microsoft Teams traffic is terrible, right? I have, jitter. I can't speak on the phone. It's all robotic. I keep getting dropped, right? Understanding how that works in the back end is really important to understanding how we can fix it. So that's a little bit about error domains. And I'm going to come back to this because this graphic is something that we've used to kind of understand how to look at the product. And it helps us kind of tell that story within the product. So with dynamic networks, I'm going to keep that kind of user, mid-mile, and then application with this 1, 2, 3 here, right? Hybrid and remote work is one of the biggest subjects that we talk about outside of security, right? Understanding end user experience. First, we have to know where they are, how they're connected, right? If IT, as I mentioned, is supporting global employees, right? Do you know anything about the home setup, right? This is some of the information we're bringing into the product to understand what's the access point, what's the SSID, what's the protocol, are we getting good signal to noise ratio, RSSI, all those kind of things we're pulling into when we're talking about remote work, because we've had, some of the craziest stories, especially through the pandemic, of people borrowing neighbors' Wi-Fi, right? Taking calls from the roof for basement offices with the Wi-Fi 2 floors up, right? We know that there are more commercial opportunities for mesh wireless right now, but at the same time, a lot of people don't update those unless the cable provider tells them to. And so understanding not only that, but which ISP is involved is really important at that user side, right? When we talk about the middle and kind of that multipath internet in the inside, it's all about resiliency, right? If you're familiar with BGP, right, it's designed for open shortest path first. That does not mean performance. That just means that it's going to take the shortest level or shortest number of hops in the macro level networks. So if you're switching from AT&T to Verizon, that's going to be the choice over going over AT&T to 3 other ISPs for peering. It may not be faster to go through AT&T and Verizon, right? It likely is in this case, but BGP is not meant to be for performance. It's meant for resiliency. And so understanding how that works and where you're transiting on the BGP perspective, the macro perspective, as well as the device and hops perspective is really important. And again, I'll show this in a few minutes here, right? So the last part is like once traffic gets to the cloud, right? You have your cloud providers. They all have kind of a special sauce for how traffic gets through them, how traffic moves throughout. And we'll mention that in the middle, or in a minute, excuse me. But we're partnering with Google to kind of help understand this. And so we're one of the network observability partners for Google, and we're pushing forward to help them understand what's going on that side, specifically for East-West multi-cloud, as well as between regions and understanding how that traffic moves because it's so dynamic, right? Even though Google owns it, they're working with providers like us to understand how they can provide a better service to their customers. Okay. So the second one I wanted to talk about is once you have that data, right, the visibility, that's the only time you can get proactive, right? It's all reactive otherwise. If you're gathering passive data, like many of us have been for years now, the network monitoring world worked by gathering data from devices we owned, from the devices that we were able to access, right? But in order to make it actionable, we do need to bring in kind of the business perspective, right? The goal is to become proactive in this and get ahead of things, right? So we understand them, not only so that we can say, oh, we can stop this, right? If it's in an ISP, you're not going to be able to stop the problem, but if you can contact them or get ahead of it, then what we've found is that IT and network operations teams get credibility because they are on top of it, because they understand what the problem is and they're already working on it. When I complain to them, they can add it to that one ticket of, hey, we have a known issue here that we're working on, and you can start telling your customers, your internal audience, that you've got it under control or that you're looking at it. And so that's going to be a real big push for the IT team when it comes to, oh, we trust this team to kind of get through these issues, as well as to maybe transform our network in the future. And so it's not just that credibility building, but this is where you start holding providers accountable with SLAs, right? We don't have a hard SLAs like we did in the MPLS days most of the times, but if we can look at something like this, which is a violation duration report, right? This dashboard shows providers that were detected in the routes that we're sending traffic over, right? And, in this case, like with this data, we can understand, where do I need to spend my time? What's the worst actor? And so you see me kind of looking up at the screen, but I'm going to switch over to the live demo to actually show this. So this is one of our dashboards. This is a violation duration dashboard, and this is essentially looking at the different applications. And so right now I have it grouped by application. So it's looking for how long have these applications been in violation of an alert threshold, right? So this alert threshold is essentially set by the metrics that we track. So it can be the metrics of latency, loss, jitter, capacity. It can be specific to voice metrics. It can be specific to a couple different pieces of the kind of connected tissue, because devices and routes, right? So this is looking kind of how long have those been violating. So what I can do is we use monitoring points. Those are essentially our agents here. If I switch these to kind of a couple specific ones, right, I can look at which ISP is actually the problem. And so if I go to one of our system tags, ISP, I can see that of the ISPs that we detected, Verso, CenturyLink, and Zayo, Verso's been the worst. And so if I drill down to that, I can look at the paths that make up or that have detected Verso through BGP AS numbers, which ones are actually the problem. And so now if I look at something like this one that's going to the Google DNS system, right, I can click that and open it up, and I can see the network timeline. Now, the first thing you're going to see here is you're going to see a timeline of events, right? This is continuous monitoring. It's something I haven't quite touched on. I might mention a little bit more later, but it's a system called TruePath for us. It is using packet train dispersion to send out very low overhead packets out over the network to mimic both data and voice traffic, right? The reason we're doing that is that it allows us to map through traceroute, so route determination through traceroute, and then it allows us to understand what the performance is at each hop. And so we do end-to-end to start and look for issues. If we detect issues with that end-to-end path, then we're going to escalate the monitoring and start going hop by hop and to understand that. And that's just using TTL through traceroute to understand which hops that we need to target. And so what we're getting here is we're getting a route diagram, right? We're getting in this case, the demonstration is just the organization I'm in. It's coming from Denver. I'm going from right here, 192.168. So you can see internal address, the gateway, firewall, and then I immediately go into Verso networks. And you can see there's one hop in Verso, and then it goes to unknown. Now, sometimes this happens where we don't get a response from the hop. That's fine. If we can understand what it's been in the past, we can look at it. If we have any other data, then we'll group it when we can. And then it's going to go to Google. And so what I'm looking at here is capacity. I'm looking at data loss. I'm looking at jitter. I'm looking at latency and round trip time. If you have the ability to put a monitoring point or an agent on the far side of the path, basically at the target, then we can do bidirectional to allow you to see up and download. Right now, because we're targeting a DNS endpoint, we don't have that. We don't own that. So we can send data against it, but we're only getting the responses from some of the hops there. In this case, I also have voice traffic set up. So if you know anything about data and voice traffic, data is usually larger packets, voice traffic is usually smaller, so that if you lose any, it's not going to be a problem because you're only going to lose a small portion of a word or a small portion of the actual audio. And so we send both of these over the pass if you decide we're going to mimic a codec. So in this case, I can scroll back up and I can see that it was G711 for the codec, right? And so this is going to have voice traffic, so specific to voice loss, voice jitter, as well as the mean opinion score. And you can see this one is very variable. And this one is one where I definitely would not want to have a call over this because, 5 is the ideal. 4 is usually, something around cell quality. 3 is not so great. And so here you can see it's actually dipping and triggering these events all the time. Now, this is a demonstration. We wouldn't often see this, but that's something to focus on. Right. So this is starting to be a ton of data, right? We're starting to get a lot of things in this that we need to look at. Now, the thing that we want to understand from triage is that if there's a problem, I talked a little bit about that auto escalation, right? We're doing end-to-end traffic. If we detect an issue based on the alert thresholds, you can see some of them here. Right. So connectivity, latency over 27 milliseconds, data loss over 0%. And it's usually based on how long, right? How long are those going to happen? Because we see spikes all the time, right? That's not uncommon, especially when you talk about switching from, one link to another. You're going to have data loss for a second, or you're going to have some issues there. So we want to have some retention of if the data loss persists for a minute, 2 minutes, then we're going to start doing something. So if we violate these alert thresholds, we're going to run what's called a diagnostic. A diagnostic is going to go hop by hop. It's going to look at every hop along the way to understand, one, where it is. You can see this one goes through Verso, and it goes to a Google Core Site data center. But if I look at the data details here, I can see that on the third hop, right, which is immediately outside my firewall, right, and my gateway, I can see it's a Verso hop, and it's got 47.86 data loss. So I've now found the hop that is a problem, right? Anything beyond that, sure, it could be the problem. But if I can't get past this, then that's going to be the biggest problem that I need to fix. And that's going to be the one that IT needs to work on. If this is a recurring issue, then IT and network ops level 1, level 2 can work with the user to maybe figure out a new ISP for them or figure out a new situation. So here's a good example of where once we have the data, we can drill down and find immediately what the problem is, right? And this is out to a DNS. So if this is, basically your core DNS, maybe we need to switch DNS or we need to find another way to do it. But that's just a good example of kind of how you do that triage level on the network side. Okay. So if I scroll back, right, this is all about reducing scope, right? Knowing where the problem is helps us focus these efforts, right? If you can tell that it's an ISP, right, that's the problem, right? I can alert internal customers from like remote employees. I can tell that it's the cloud provider. I can tell them that it's, not on their side. It's not on the app side, right? I have the credibility, but I also have the data and the visibility, right? So I've looked through that diagnostic here, right? In this case, we get all the way down to the diagnostic and prove it's not our infrastructure. In this case, the remote employees infrastructure, right? It's not something we can fix, but it is something we can talk to the ISP about. We may not have the kind of the pull within the ISP for a specific residential customer, but if we're a corporate customer, that's a different story, and we can start talking about what we might want to do with that. Okay, so right, we've long kind of lived in the rules of like loss, latency, and jitter, and so that's what we start with. That's data that we have. You saw that in the example. But I want to start looking at a few more metrics that we can bring in, right? The method of collecting these metrics has to change for third-party networks, right? I've talked about it a little bit, and maybe I haven't explained it perfectly, but active monitoring is the idea of sending test traffic over the network in which to monitor it. And so we're not just collecting passive metrics like SNMP, BGP information. We do collect those. Those are still in there. But the idea is sending out traffic over time, and that's using TruePath, using our packet train dispersion in order to measure the network. And by doing it continuously, we not only get these charts that show you loss, latency, jitter, capacity, all of these over time. But we can also do that from the network perspective and the application perspective. And so we do it from the network perspective with TruePath. From the application perspective in the top left here, we're actually doing it through either HTTP curl or we're doing Selenium-based synthetic transaction monitoring. And that's going to give us things like this top network server browser breakdown, which I'll come back to our experience module in a second, which is a whole nother part of the product that we haven't dived into yet, but we'll talk more about the application context, because the issue is that at the top level, we still have that problem of the age-old question of, is it an app problem or is it a network problem, right? And the goal kind of with this is to cut it in half at every step, right? So within the workflow, we figure out app or network. We can understand if the app is up. Okay, if it's app, is it DNS, right? If we own the app, we may be able to go down to cache, database, timings, things like that. If we don't own the app, we might just be able to see like a status page or to see if the application is up from different locations. If it's network, right, then we can drill down, right? If it's owned by IT or if it's a third party. So owned versus unowned. I often say owned versus unowned or managed versus unmanaged, right? They're all managed, but the idea is that we don't manage it. So if we own the network, right, then the metrics we need could be around connectivity. It could be CPU, SNMP. If the Mac or PC for the end user is not working. If it's unowned, we need to find out where, right? That's where we need to isolate the scope. And so can we isolate it to a specific part of the network, to a specific ISP or the cloud provider environment, just so we can understand what's going on and we can kind of take ownership of the problem, right? And I want to harp on that concept of isolating where an issue is. And so you saw earlier when I talked about error domains that we had that kind of user ISP transit and then cloud or application service provider setup. And so that's what we're seeing within our route diagram here. So, the where is really that biggest thing. It gets us excited about these active approaches because it allows us to isolate where the problem is happening, right? This shows the aggregation based on the network. So you can see, and as we saw in the demo, CenturyLink, TELUS, Level 3, as well as Google, we can see these different points. And that's just looking at BGP data, but it's also looking at, the IP address itself to understand subnets, things like that. So through continuous monitoring, and this is using traceroute through ICMP, TCP, and UDP, right? We're not only seeing the different paths over time, right? You can see these darker lines versus these lighter lines. So this is over a time window. We can see how often or how likely traffic is to go over one based on what we've seen historically on data there. Right. But during triage, we can actually go through the time slider and switch back and forth. And so if I actually flip back here and I go back one or two here. So I have this route over time. Excuse me. If I go to the network pass page and I've switched on the hop view. So here I can see that Denver monitoring point that we were looking at before, as well as the Vancouver one. And if I go back in time, I can actually see how those networks flip and change. And so that allows me to understand when an issue happened. And so if I got reports that all of a sudden performance changed right at 12:34, right, I can understand what happened there. I can understand that in the Microsoft network, right, we switched from one link to another. Right? If I go into the network view again and I open that up, I can see that it's happening within the Microsoft network. I can see that it's load balancing in front of Office 365 in this case. And so I can understand that it's not one of our problems, right? It's not a corporate problem. It's not within our infrastructure. It's within the Microsoft infrastructure. And so that's very helpful from that standpoint. Okay, so if I go back here, right, we run that trace route. We run that as route determination. It's not how we do the monitoring. It's just the first step, right? And so we can see that hop by hop where traffic is going, and that's what we're going to use to trigger the diagnostic and go hop by hop, right? Diagnostics are not a magic bullet, right? We can only go through so much. So we can run a trace route. We can tell you how far we get and work back towards the problem. So in that case that we showed earlier with the 48% data loss, right? That's one where we can see exactly where that happened. After that, we're not going to be able to see much there, but we can rule out the rest of the network path, right? So it's time saving, it's isolating scope or narrowing that. And the key to all of this is that it gets very dynamic and kind of complex, right? If we start looking at all of these different endpoints, we want to find out if we can respond before customers are impacted, before it impacts our productivity or even our brand. And the idea of mean time to innocence is one that we're not unfamiliar with, right? It's how fast can we prove it's not our problem or it's not our responsibility within that war room. And the idea here is that we're giving everyone the out, and it's not just pointing at the network and saying, well, it's not the app is up. The network's a problem. Is it our owned or unowned network? Where is it in the network? We can start giving you those information. Okay. So with that, I think I'll flip back over here just to kind of show one more thing on this side. So we call this our multipath route visualization. But if I go and I specifically look at Office 365 in this case, right, I can see what the different links are. So if I didn't know where this user was, I can see the ISP and I can see where our traffic is going. So I just want to make sure I highlighted that. Within each one of these, we can also see what type of connectivity they're on. Are they on Wi-Fi or are they on wired? Right? What was the last diagnostic? How often have they violated? So we can start using these to understand a group of people and really look at that in a different light, because we can understand where that traffic's going and how it changes over time. Okay. The last of the best practices that I want to talk about is really around the validation piece. So apps are complex. We know this, right? This is something that, many of you may be more familiar with, right? We've talked a lot about networks and kind of the whole app versus network, right? We do need the app detail, right? Google and Microsoft and AWS offers a lot of good application data or cloud data if you own the app. If you don't own the app, you often have to end up talking about status pages. And so we need to combine these data sets to get the whole picture. And so if I basically talk about the last two pieces of the product, I want to give the application context. So if I switch back to the demo for the last time here, I'm going to switch to experience first. These are web app groups. So these are using browser-based Selenium scripts. And what this is really doing is it's allowing me to see what the application is basically or how it's performing. AptX score is love it or hate it. It's a comparison metric. It allows us to see generally how things are going. But if I click into the Denver monitoring point here, what I can do is I can see that we're targeting accounts.google.com. Google Workplace is the script. I can see a network server browser timing. So network transit, the server response, and the browser render. That's what we're looking at here. I can also look at it by milestones. So when you do Selenium scripting or when you do application scripting, the goal is not to just hit the login page and be done, right? You need to go into the app. You need to use it because oftentimes applications are microserviced out. They have multiple different endpoints. They have different page loads, or they're a single page app that doesn't do page loads. And so you need milestones to kind of understand what the different logical breakpoints in the workflow are for the user. But if I click on any one of these, well, actually, before I do that, I can look at the timing, I can look at aptX, and most importantly, I can look at DNS response. And so if I have multiple DNS responses here, I can click all of those and I can see if you have, one DNS that's working better than others or one that's falling over, but it's hidden because the fastest response wins, then you're going to be able to see that with the DNS monitoring, right? If I go back up to the top here and I click on any one of those bullet points, I can look at the actual full waterfall chart. And so that's the big thing is I can get to the full waterfall chart. I can get to the timings. I can get to all of that from the application context to make sure the application is not the problem, right? We're monitoring apps from behind the firewall. So from our end user perspective, so we're getting the full kind of end-to-end transit of this application. We're getting the network context for the applications, and we're using these milestones in waterfall. The last piece that I haven't talked about is a passive monitoring solution. So it's the idea of using, looking at all traffic, right? So identifying applications based on the network headers and understanding that. We use a DPI engine, so deep packet inspection engine that allows us to understand what applications are running. This is a user at home in Denver. You can see YouTube TV is one of the biggest one, as well as they're doing some testing. If I look into this specific location, what I can do is I can start seeing the top applications, the top talkers. I can look at everything from network latency, application latency, TCP retransmits. I can really break it down to see what type of stuff is going on. So I can see I've got OneDrive. I've also got Quick, which is a protocol for Google Drive. If you're not familiar, I can see how many packets, flows, all that kind of stuff. And what's great about this product is that within this scope, if I have a monitoring point at the edge in this user location at an office, I can also do remote packet capture. I can schedule those or manually trigger those so I can understand exactly what's happening. So when you do need, packets at the end of the day, sometimes for triage, you do need to, test something out. We can do that with this same solution. And so that's where it becomes very powerful, as we combine that network, that application, as well as the specific packets and flows all together. And so with that, I want to finish with just a couple major points. So active and continuous monitoring is a huge part of what we're doing here, right? You can't be successful if you're purely reactive, right? Because the solutions are dynamic, or because the networks are dynamic, complex, right? You can't just pull a monitoring off the shelf and use it when you want, because you're going to miss issues, right? We have people that have to kind of tune monitoring to make sure that they're not paying too much, right? We get rid of all that with a better licensing model and all that. I don't want to get into that part of it today. But the idea is, you pick the targets, the applications, the locations you care about. We're going to monitor them every way we know how, and we're going to do them active and continuously. We're going to bring in passive data when you need it. But the idea is that active, continuous is the only way to get to a proactive stance. It's the only way when you're doing network transformations to kind of baseline application performance before an issue or before a change, validate during it, and then continuously monitor after it. And the last part is that it's a long-term project, right? The growth in the cloud is not slowing down. The network's going to become more complex. It's more dynamic, and you need to plan for it, right? So whether it's understanding the new network constraints with remote employees, right? Everyone taking Google Meets from their desk instead of a conference room because we've all gotten used to doing it, multitasking on the side, right? Every new technology that we use or put in place also needs to look at security. It needs to see how security impacts performance. And then the tie back here is really, right, remember about the visibility, right? Something that every part of the organization is accountable for is visibility into these. And that's the whole idea behind the observability word. And I could get on a soapbox about that, but the idea is that design the system so that it's observable, right? That's the goal of observability. It's not a buzzword. It's not just AI. It's design your system so that you can get the metrics and the data you need out of them. And this is one of those tools. Active and continuous monitoring is one of the things you need. You still need passive. There are a bunch of different components here, but getting it all together is really the core part. So when I come back to the end here and say, right, this whole talk is around 3 ways to enhance user and app performance, but it was really all about the network today, right? We need to first embrace the reality of the dynamic network, plan for that change. We need to get more data and make it actionable. And then we need to monitor from the outside in, from the inside out, from different perspectives, from the end user perspective, from the app perspective. We need to get all of those components together. And with that, with all of that data together, then we have a better kind of seat at the table as network operations and as the network team. So with that, I want to thank you, and we can move over to questions.
Yeah, outstanding, Alec. Clearly a man who's made a few presentations in his day. that was epic. Well done.
Appreciate it.
So I was writing all kinds of things down, but one of the things I noticed early on was you were talking about the trade-off between security and performance, and one of the other trade-offs, and we're seeing this with other solutions that we're covering, is this idea of the end user experience. So can you talk a little bit about, the decision makers who are looking at a solution like this, how they should be thinking about that trade-off between security and end user experience?
Yeah, I think it's obvious that in the world we live in today, and specifically with the amount of data from corporate entities that is traversing the open internet, security is a priority. We have to have security. I do think there are a lot of apps out there today that, when you really look at them, are either not dealing with data that needs to be as secure, beyond just normal encryption. We talk about data sovereignty. We talk about where data needs to be housed, all that kind of things. I do think security is very important. I think at the end of the day, we are much more secure in a lot of ways than we used to be. And therefore, when we are comfortable with the security level, we need to then look at where the end user experience comes in, because performance, when you're remote, performance when you're in the office, right? We all have a lot to do when it comes to our jobs. And so when IT gets in the way, it really hurts the credibility of IT, which means that it becomes very difficult for them to pitch new transformations that might make you more secure or might make you more productive. And so I think while I work for a monitoring and a network performance company, security does often come first, right? Once we have a level of security, we need to look at the impact of that. And so I would say when you're implementing new security or new technologies, SD-WAN, SASE, all those kind of things, look at the impact on performance. And oftentimes that's why I go to the kind of before, during, after mantra of baseline application performance before, then make the transition, validate that it hasn't destroyed the productivity and the experience, because it will have an impact, right? As long as it doesn't have a major impact, we should be in the clear there for experience.
Yeah, and it's interesting how again, in the evolution of technology, the satisfaction of employees with their digital experience is becoming so important, to the detriment, I think, sometimes of security, which can be a little
we
risky.
had a lot of people who came back from the pandemic and said, look, my performance is better from home. Not just productivity, but my internet performance is better from home because the office had way more security in place. And that was a wake-up call for IT teams to say, we need to make sure that performance is at least good or better at the office, because it's not just a 1 gig link that we have at the office. It's the firewalls, it's the DMZ, right? It's the packet inspection. It's all of those pieces that need to be as like part of the discussion. And I think the funny part is, IT starts to get a bad rep if you're sitting there saying, hey, I could get better from Comcast at home, right? That becomes a big back and forth between, trust in the network operations team versus, what's the performance of the actual network.
Yeah. No, we could go on and on, but I'm getting some questions, so I don't want to get sidetracked. I apologize. So one question, pretty straightforward question, is how's the solution deployed in order to get the visibility that you've described?
Yeah, so a big question, just because we're all technical people here, right? We're if we want to know just how it works, right? The way that we deploy is we have a ton of different ways to put a monitoring point or an agent in different locations, right? If you're in an office, we have purpose-built hardware appliances. If you're in the cloud, we have VM, right? We have VMware and KVM Linux. We have containers through Docker, right? We can use the NFV space on some switches to put a container as well. And so there's a lot of different ways we can do that. If we want remote work, we can have agents. I have an agent running on my computer right now. It's often very good for showing demos to show that you can look at your own Wi-Fi and see how it's working. And then the biggest thing about the solution, which I think is really important for some people, is that we can deploy this as a full cloud service where all of your monitoring points are sending data to the cloud, or we can take it entirely on-prem and it will just live in your data center or your headquarters, and we can send all the data there and completely cut off from the cloud, because we know that's still a reality for some industries.
Well, you mentioned observability, and we have a question around, can the solution export this data into Grafana, which is an open observability solution?
Yeah, and I think Grafana and others, right? So we've heard that request a lot. Specifically, it's often for exporting data to a knock screen or bringing it into another. So absolutely, REST-based API. We have it through Swagger that allows us to kind of touch anything in the product. So it's any type of data. We can export data. We can do bulk actions, configuration. We have some customers that do on-demand network path creation. So when a new monitoring point comes online, automatically sets it up, puts its testing in place, and it's ready to go within minutes.
And I know you mentioned it, and I think I know the answer, but I don't want to skip this question, which is, does this work with Microsoft Teams?
Yeah, so we have a couple different things that we can do with Microsoft Teams specifically, as well as any other kind of UC as a service. Specifically, is the idea that one, we're testing voice traffic as well as data traffic, so we're doing both the visual and the audio. We're also hosting what we would call a monitoring point or a global monitoring point or target within Teams regions. And so you can test out to those to understand exactly what your performance is to the region that's hosting your meeting. And that's really helpful for global footprint type companies where you have to deal with understanding kind of how people are transiting different backbones within the Microsoft infrastructure to understand how exactly they're getting to those locations and what the performance is over that. So we can do a couple things there. And I think the end of the day, the idea is really make sure you have the voice metrics, because that's going to be the biggest part of understanding what performance is, right? If you just have data, you're not actually seeing the whole picture. So absolutely.
Yeah. So so one of the questions I always like to ask, and I'm a big fan of engaging, and I would encourage everybody watching this to reach out and actively engage. You'll get to talk to smart people like Alec here, and so there is a place on the Broadcom site, broadcom.com/appneta/demo, where you can book an AppNeta demo. And I'm curious, because that's right where you kind of start to jump into the process with them. What does that begin to look like? How does that kind of spin out for somebody who does decide they want to engage in a conversation?
Yeah, so the first thing we're always going to do is we're going to ask a bunch of questions. We want to understand what your environment looks like, what your pain points are, what's the issue that allowed you to reach out, or what intrigued you. All of the AppNeta work that we do goes through a proof of concept. We're not just going to sell you something and run away, right? The idea here is to work with you to help you set up some monitoring, help you set up some critical monitoring links, so that during the proof of concept or proof of value phase, you can see your own data. You can see your own data center, your own traffic in there. If you have internal applications, we can set those up. It's real easy to do, but obviously we're the experts. We have it. So we want to make sure you see the most value as quickly as possible. So the demo is just the first start of the conversation. We like to do a long process of back and forth to make sure you know what you're getting, what your value is, and we know that we can help you, right? We're not always the best solution for you, but we want to try. And so give us a chance, and we'll do the proof of concept stage.
Yeah, so along those lines, because I think everybody usually has something, and they might be point solutions, they might be cobbled together, it might even be a little homegrown. What advice would you provide or offer to somebody thinking about taking that step toward a next level solution like this, even though they may already have something? I mean, what would you suggest they think about, how they might want to position it internally, who they might want to gather together to talk it over? I mean, what advice would you provide when they to get to that next level?
The best part about AppNeta for us is that the active monitoring sphere is a pretty small one. There aren't a lot of solutions that do this same type of active monitoring. In fact, our proprietary TruePath is obviously just ours. There are some that are out there that are going to give you traceroute. They're going to give you some ability to see the route. I would say look for your network blind spots, right? What parts of the network are you having trouble with that you don't have visibility into today? Because I can guarantee you that we can probably see into it, and we can give you some visibility back that will help you find some issues. I think looking at how long it's taking you to get to root cause, right? That is one of the focuses of Broadcom as well as AppNeta, is the root cause analysis side of how fast can we get you to understand where the problem is, whether or not you can fix it, right? If it's external, if it's not in your environment, at least knowing where it is going to be a big step in kind of the triage process and the troubleshooting process, and especially in war rooms, right? And so I would say start looking for blind spots, and then look at what active monitoring could do for you. We're very complementary with a lot of other kind of network systems right there. Broadcom obviously has a network, a very good network monitoring solution for on-premise as well. And so you don't have to have both of our systems, right? You can look at AppNeta and see if that's a good solution for the problems you have. If it is, great, let's talk, and the rest of it can happen in the future. We don't have to worry about that.
Yeah, this has been great. Alex, we really appreciate the time. You clearly know your business. It was a pleasure to watch you present, and thanks for those answers. Again, we would encourage everybody to explore and engage. These things are usually best discovered through that interaction with the solution provider and smart people like Alec. So very much appreciated. Thanks very much for the time today. Best of luck in the new year.
Thanks so much.
Well, there you have it. Another solution in our spotlight. We want to thank Alec and AppNeta by Broadcom for that fine presentation, and we appreciate your attendance as well. Until next time, I'm Doug Atkinson here at Solutions Review. Thanks for watching.